Today, we're going to talk about calibrated devices, and we have two reasons we're going to talk about them. Number one is the quality system requirements, and number two is the 510K requirements. And I'm going to actually cover number two first. Now, first of all, for those people that don't know what we're talking about when we're talking about calibrated devices, usually it's something like this: a 6-inch caliper, or a micrometer, or an optical comparator, or a CMM machine, some kind of device that's used to measure something. And you usually need very precise measurements and you want them to be repeatable. Well, if you want to make sure that you're going to get very precise measurements that are repeatable, you need to use a calibrated device. And you calibrate them against a known standard that you're absolutely confident is the correct measurement. So if you want something to measure 1 inch, you have to have maybe a gauge block that is exactly 1 inch. That would be just a steel rectangular block that is 1 inch in dimensions. And it's usually exactly 1 inch in dimensions with several zeros after that decimal place. And the rule of thumb that we use is we want to have whatever we're using to establish calibration be at least 10 times more precise in the number of digits than what we're actually requiring as a tolerance. So if our tolerance is 1 millimeter, then we want something that is accurate to 0.1 millimeter. If we're trying to measure 0.1 millimeter, we want it to be 0.01 millimeter. You get the idea. Now, could you do this with something that's a little less precise? Yes. But the less precise it is, the more possibility is that the error in your in the standard that you're using to establish the calibration is greater than or equal to the amount of tolerance that you're trying to measure, and you could get some erroneous readings. And they're not as precise as you're claiming they are. Now, why would this be important? Well, if you're trying to put a catheter through a guide sheath and you have the wrong dimensions, it might get stuck. It might scrape off the coating. It might get stuck in the tortuous path that you're trying to insert the catheter through, such as somebody's brain during some sort of aneurysm or stroke. So this could be life-threatening situation just because you don't have the measurement correct. Now, for other things, if you're measuring the width of a package that you're going to put something in, plus or minus a half an inch might not matter at all. Whereas plus or minus a thousandth might be absolutely critical in another application. So it depends on what your needs are for the job. And you have to establish, oh, this is the tolerance I need. This is the accuracy. This is the precision that I need. And the way that we know these devices are calibrated in the first place is we typically will have a sticker on the backside. This does not have one. So the sticker on it would say what the gauge ID is. It would say who did the calibration of that, oftentimes just initials. It will say the date that it was performed and the date that it's due for recalibration. That's all that's the information on there. So you have to have a different system for keeping all the records of your calibration. What you're going to have is you're going to have maybe a long list, maybe an Excel spreadsheet, or you're going to have a software program like GaugeTrack that's going to have all your list of calibrated devices. And then typically when you click on that, if it's an electronic system, you're going to click on that record link, and it's going to open up the record that you need, and it's going to tell you all the details of that calibration. If you have more of a paper-based system or a virtual quality system, then you're going to look on the log and you're going to see, oh, this is the record, and you're going to go to the location where you have those records stored, and you're going to look for that record number, and you're going to pull it up. And often they're sorted by the calibration ID number. So you might have a separate subfolder for every single calibration ID number, and some small companies might only have 2 or 3 gauges. A large company might have thousands of gauges. When you have thousands of gauges, to load level the work, you're typically going to spread that over months. So each month you do, let's say, 100 gauges. And over the course of the year, you're doing over 1,000 gauges. And it's certain times of the year, you might have a special company come in calibrating gauges that you're not able to do in-house. They might require special tools that you don't have, or you don't have the training in order to do that. So that's the basic process that is used for managing your calibration program. But when it comes to a 510K submission or a CE marking submission, any kind of regulatory submission, the device that we use to measure things during our design verification, design validation matters. They want to know that that device was appropriate for doing the measurements. So, for example, if we're measuring the amount of UV light that a device emits for safety purposes, we want to make sure that the optical measurement device that's able to measure that UV light is appropriate for the task. If you have an opening that's the wrong size, it might underestimate the amount of UV light that's being emitted by the device. And so you think it's safe, but just because you use the wrong device to measure it, it's not giving you an accurate measurement. So there's actually some calculations that they'll do to actually determine what needs to be the size of the aperture for your optical sensor to make sure that it's able to capture the amount of light that's being emitted by the opening in your device where the light's coming through. And if there are lots of ways to calculate this, but we recently were working on a submission where the FDA actually asked that question. So we had to go back to the company that did the measurements and actually ask for those details. Now, they could just take the company's word for it, but they often don't. Regulators will ask, can you please give us the calibration ID number for this device? Can you give us the dimensions? Can you give us, just like any measurement, they want to know that you use the right tool for the job. They don't want to just take your word for it. So, what is the best way to document this? Well, from a very simple standpoint, at a minimum, you want to have traceability of the gauge that was used so you can go back and get any information they're asking for that you didn't include in your report. What's the simplest way to do that? Yeah, you can type it all out, but you can make mistakes when you type. And it takes time. So the simplest way is to just grab your cell phone. Where's mine? Not even sure right now. So you snap a picture with your cell phone of the calibration ID sticker. Now, I don't have a calibration ID sticker on it, but it's typically on the back side of the caliper. In other devices, it'll be in different places, but you would snap a picture of the calibration ID number, and that's how you know what device you used. Now, if you watched one of my other videos that I've done recently about how to manage calibration of gauges, I give the example of a gauge pin. This is just a round pin made of metal. It's usually stainless to prevent rusting, and it has a very precise diameter to that round bar. They've actually ground it with centerless grinding to make sure that it's exactly those dimensions, and they grind a little bit more and grind a little bit more until they get exactly the measurement they want, and then they stop and they polish it, and they're done. Well, if you want to make sure you know what those are prior to use, what you will do is you'll take that gauge pin and put it in a micrometer. But there's a special kind of micrometer that most companies will use when they do this a lot. It's called a bench mic. It's an actual micrometer that sits on the top of the bench, so it's stationary. It doesn't move around. You don't have to hold it with your hands. You hold one hand, put it in the gauge. You gradually tighten down the gauge until it's holding the part. So that means it's not so tight that it's actually gouging the part, but it's tight enough that you know that's the actual dimension. And then you record that value and you say, I've verified that it's the right gauge with this bench mic. But because the actual gauge pin is not calibrated, what you would do in this situation, if you want to put the information in a report, snap a picture of the bench mic measuring the device, the gauge pin that you're using, and then snap a picture of the calibration ID for the bench mic. So now you have both. You have confirmation that prior to doing this, you verified the calibration of the gauge pin, and you have traceability to the device that was used to verify that calibration, the bench mic. And then if you pull up that calibration ID, you'll be able to get the full test report on how they calibrated that bench mic. So that's a fairly complicated way to explain it, but it's really simple. It's two pictures. here's one of the gauge being measured, and it actually shows the measurement on the digital reading or analog reading. And then there's a second one of the calibration sticker. And that's all you needed. You didn't need to type all that out. With those two pieces of information, you can go back and get anything that they want. But the FDA should be much more clear. Okay, I can see from the readout on this what kind of precision that gauge is, and I can see it's calibrated, so I don't have too many other questions. If they can see the aperture of the device on that optical reader, they might know, oh, well, that's the appropriate size for what they're trying to measure, or oh no, that's not the right size, that's completely wrong, or I'm not sure, it's right in that range where it's a gray area, I need to verify. So you might actually be able to avoid some simple questions just by showing them a picture. Keep in mind, a lot of the people that are reviewing your submissions haven't actually worked in a metrology lab before. Maybe they haven't designed a medical device before. They may have the technical expertise in terms of science, math, or engineering, maybe even computers, but they might not have actually done the hands-on work that you're doing. So there's a little bit of a learning curve for them, and pictures really help explain things and help them visualize things that might be hard to understand. So always snap a picture, include that in your verification records. And you'll see a lot of times when you get an electrical safety or an EMC testing report, they'll actually snap pictures of the setup. That way they can repeat the setup next time if they have to do a retest, and any questions that somebody might have that are not captured in the test report, they're clarified with the pictures. Also, if the FDA comes back or the company comes back and says, could you give us some more detail? Oh, based on the picture, I can tell you this answer. Keep in mind, people don't stay in their job forever and ever. So it's possible that that person that did the test might no longer work at that lab. And so somebody else has to look at the test report and figure it out. Like, oh, I can see from the setup, he used this piece of equipment. I can get that information for you. So labs that are third-party labs doing the testing for you, they may not always put the detail in the report, but they often use the best practice of snap a picture and attach it to the report to clarify things for everybody that's reading the report. So today, that's our advice on how to manage the calibration of your devices and how to make sure that you are getting that information in your validation reports. If you have any other questions about calibration, please don't hesitate to put the questions down in the comments below. And I'm also going to put a link down there for our new calibration procedure. It's not necessarily new, but it's been updated, and we put that in there, that link in there for you if you need a calibration procedure. You might be a company that outsources and says, oh, we don't need it. And then the notified body says, no, you need it. Even though you're outsourcing that, you need to understand how calibration is supposed to be managed and explain that in your procedure. So that may help you. If you have, like I said, any questions, put them in the comments below. And I hope this week's tip was helpful. If you have any suggestions for next week's, we're probably not going to have one next week because next week is Thanksgiving and I'm going to try to take Friday off. But if you have anything that you want us to cover the following week after Thanksgiving, be very thankful to get your suggestions down below. Have a great day. Bye-bye.